Hey guys, welcome to a video. Now let's look at paper 2, okay, for mid-year exam. So first question in section A, distance time graph. When they tell you distance time graph, first thing you gotta know is that in the distance time graph, what does it tell you? It tells you two things. First thing, other than the distance and the time, it also tells you that the gradient gives me the speed, right? Okay, so that's why when they ask you describe the movement from 10 to 15, so here to here, what can you say about the gradient here? Constant gradient means constant speed. That's right. Okay, so this one, just one mark for this. Okay, next one, they ask you to calculate the average speed of the motorcycle for the whole journey. So average speed is simply total distance over total time. So what's the total distance? No need to find anything about area. Area is only for speed time. So distance, I told you can tell distance and time, right? So total distance is just 300. Total time 15. That's it. So just 300 divided by 15, we get 20 meters per second. Okay, one mark, one mark. All right. Okay, that's it for question 1. 3 marks. So go straight to question 2. Okay, you see a jet ski over here suddenly brakes with a constant braking force. Calculate deceleration. So if I were to use the formula F equals ma, deceleration constant braking force is simply 2000 equals to mass, which is given 400 times A's acceleration, so you can find A is equal to 2000 divided by 405 meters per second squared. That's it. Okay, deceleration will likely be higher. Explain why. Okay, why is it higher? Because if let's say it will be, okay, additional forces. All right, additional forces acting on what? On the ski. So where will you put the additional force? So the additional force will be over here, right? So since the additional force, in other words, my braking force will be bigger. Alright, so since braking force is bigger, if this value is bigger, my acceleration will also be bigger, because 2000, imagine with a water resistance of 1000 plus another 2000 here due to the braking force, 3000 divided by this, so this will be a bigger number, right? So on the ski, okay, there will be additional forces acting on the ski, resulting in what? Higher resultant force and higher as a deceleration. Okay, all right. Okay, question 3. Okay, what's the formula we use here? Just this is W, this is G, so W equals mg. In other words, G over here is equals to W over m. So where is W? W is 147. Okay, divided by m, which is what we don't know. Okay. Oops. Okay, m is over here, is given for part 2. So this divided by 15. So this divided by 15, 147 divided by 15. The first answer you'll get 9.8. 24.6 divided by 15. Okay, I'll get 1.64. Okay, so define gravitational field strength. So gravitational field strength is simply just a force, gravitational force acting on an object per unit mass. Basically just come out with the definition. That's it. Okay, all right, so next one. Okay, we are in 3B right now. Okay, 3B. So after a month, the mass of the piece of meteorite is found to be 14 kilograms instead of 15. Scientist A says the difference in the gravitational field strength of Earth and Moon likely cause a reduction. So, we will cause a reduction, but not in the mass, right? It will only cause a reduction in the weight, so it doesn't change the mass. Mass is independent. So the only scientist which is likely correct is B. Okay, because you say a piece of meteorite may likely have fallen off. Because if you lose mass is the definition of mass is the amount of stuff in an object, right? So if you lose mass, probably you lost the stuff. That's it. Okay, so this one will be, which one is correct? So scientist B. Okay, explain. Because mass is amount of matter in object and does not depend on what? Gravitational field strength, right? Gravitational field strength. Okay? Okay, question 4a, this was quite well done. Okay, work done. It's simply just force times distance. Force, they already given you force over here to a distance of 0.4 meters. So 6,000 times 0.4, this gives us 240 joules. Okay? Next one over here. What's the power output? So power is simply work done divided by time. So just now we had 240 joules. But remember, how many presses did he do? He does 30 over here. So times 30 divided by, this is where most people get wrong. You forget to change this to SI unit. It's not just 1 minute, but 1 times 60 seconds. Okay? So the answer here will basically be 120 watts. That's it. Okay? So that's all for section A. Let's go straight to section B. So this one just to plot a graph. So plot, just remember every time you plot must put an X. So 0, 0, 520, so 520 here. 10, 40, 10, 15, 20, 25. So the next 4 points will all be at 40. So 10, 15, 20, 25. Okay, and after that 30 at 0. 30 at 0. Okay, got it? So after you come up with this, the rest is just draw the straight line. So make sure when they ask you to plot, make sure you get your plots here. Don't just put a faint dot. So you need to actually plot it out by putting an X there. So just join it, straight line. That's it. 2 marks, easy. Okay. So part 2, describe the motion from 10 to 25. So 10 to 25. What can you say about the motion? This is speed time graph, right? So speed time graph, just say constant speed. That's it. Right? Okay. So next one, they ask you calculate the total distance for the whole journey. So distance, how do you calculate those distance in speed time graph? So distance is just area under graph. How do you get the area? Okay, you can split this into 3 shapes. First shape here, the triangle, plus second shape, rectangle, plus third shape, triangle, right? So triangle, rectangle, triangle. Okay, so what are the dimensions here? So you got 10, 40. Here will be how many? 15, 40. Over here, 5, 40, right? So if I were to just slot in the formula, half times base times height. First one will be half times 10 times 40 plus the rectangle will be 15 times 40 plus half base times height again. That's it. Final answer, 900 meters. That's it. Okay. So the first part of the first question. So over here, time t equals 0, time t equals 10 seconds. From 10 seconds to 25 seconds, draw and label frictional force R. Okay, so 10 to 25 is constant speed, right? Just now we mentioned, right? So at constant speed, if I have a forward thrust of this amount and experiences a friction of this amount, they ask you scooter's back wheel, right? So how do I draw this? Okay, so it must touch the segway and point to the left along the ground. Okay, so R, we must touch, move to the left, label R. That's it, 1 mark. State the value of this frictional force. What do you think? Since it's at constant speed, it must be 850 newtons. That's the first part, right? They ask you explain how it can be obtained. That's the second part of the question. Okay, so we can say since constant speed, resultant force equals 0 Newton. Therefore, thrust equals to friction equals to 850 newtons. Okay? Alright, so this is the key here, right? Okay. Question 6. So I've got some density mass. Just remember for this type of question, you can add masses, you can add volumes, never add densities. That's the key here. So first one, calculate total volume of chopnam used in the tank. Okay. So total volume. So you can see I can actually have one more column here. Volume. If I draw this, density equals to mass over volume. So mass equals to, volume equals to mass over density. So this one is 4320 divided by 4500. Okay. The second one, 9072 divided by 6300. Alright. So total volume is this and this lah. So 4320 divided by 4500 plus 9072 divided by 6300. Okay, so this final answer just gives me 2.4 meter cube. Okay, you see I can add both of them, right? Okay. So density of chopnam, same. This is where the mistake most of you actually made. Okay, you cannot add both densities. You got a total the density of the whole thing. It has to be total mass divided by total volume. Okay, so what is the total mass? How do I get total mass? This plus this, right? So 4320 plus 9072 divided by, what's total volume? We got here 2.4. Right, so divide by 2.4, we will get equals to 5580. Okay, so given the density of water is this, explain why the tank is still able to float. So, densities of chopnam does not include the air particles, right? So how do you actually explain? Okay, so even though chopnam has higher density, but what can you say? Average density of tank is still lower than water because, here's the key, why? Because of the large volume of air in the tank. Okay, so the keyword will be what? Average density of tank includes large volume of air. Yeah, okay, got it? Alright, I think this is the last part of this question. Okay, so explain what is pressure. So pressure is simply just force per unit area. Okay, the side of the tank has a surface area of this amount. Calculate the maximum force that the side of the tank can withstand. So if you just simply use pressure equals force over area, force equals pressure times area, which equals to 20,000 is given. 20,000 times 15. That's it. Answer 300,000 newtons. Alright. Okay, next we got this. An acrobat on a teeterboard. Okay. State the principle of moments for body in equilibrium. Okay, this one just sum of clockwise moments. Gotta spell it out, okay? Is equals to sum of anti-clockwise moments, okay, about the same pivot. Alright, so describe, explain how the position makes the teeterboard more effective in launching it. Okay, so from principle of moments, the anti-clockwise moment equals to clockwise moment. So what you can say, why does it cause, why is it more effective? Okay, it's because there are two things. Okay, over here, let me show you the trick here. Okay, the trick here is to use m equals to force times distance. To create a large force, I must have a small distance for the same moment, right? Okay, so the small distance, you can say the small pivot distance on the right results in what? Large force on the acrobat. Okay, because of this, right, it must be the same. So if you were to zoom into the formula, if I have a very large distance, it will cause me a small force. Small distance cause me a large force. Okay, so I will come straight to this one right now. Okay, how do you solve this? I have length times force times distance equals to force times distance, right? So just L times 5 equals to R times 1. So where's L? L given as 2,000 times 5 equals to R times 1. In other words, R is equals to 10,000 newtons. Alright, that's it. Okay, last part of the question. Okay, when the acrobat lands on the teeterboard, he has a kinetic energy of this. So KE, mass of the acrobat is this. Assuming all kinetic energy is transferred, calculate the speed of the acrobat. Okay, so kinetic energy equals a half mv squared, right? So if I substitute kinetic energy, half m, which is 50 v squared. You see? Can you find v now? The rest is just mass, right? So v equals 15 meters per second. Let's bring this over the other side. Okay, so acrobat B will not likely achieve the speed. Explain why this is so. Because energy is lost in form of what? Thermal and sound energy. Okay, that's it. Okay, hope you enjoyed this video. Okay, I'll see you soon.